scientists, in their never-ending fascination with light, set out to devise ways of isolating smaller and smaller units of it. It proved to be the passageway through the looking glass. It was the crossing of a threshold into a wonderland where the known rules of physics do not apply. For the first time, they were able to isolate the tiniest unit of light, a single photon.
To be fair, the question of what light is not an easy one. For centuries, the greatest minds in science debated this issue. In the late 1600s, Newton proposed that light was a stream of particles, or corpuscles. But at the same time, a Dutch physicist named Huygens proposed that light was a wave, and this debate raged on until it was settled.
You may know about or remember one of the most famous experiments in the history of physics. The experiment of Thomas Young, the double-slit experiment. It was a real coup in physics and led many scientists into the study of quantum mechanics. If you throw solid balls at a shield with a slit cut into it, a single diffuse strip designating the strike points will appear on the screen behind the shield. If there are two slits in the shield, then there will be two strips. But how will waves behave if aimed at the shield? They will pass through the slot and spread out. But if you add a second slit, everything changes. A number of alternating interference strips will appear on the projection screen. And when we shine light on the two strips,
This is exactly what was happening with the light. When the light from one slit met up, peaks with peaks and troughs with troughs, they constructively interfered and produced a bright spot. But if the trough from the wave from one slit met up with the peak of the wave from the other slit, they would destructively interfere and you wouldn't see any light there. It's light canceling itself out.
And this is how Mr. Young proved the wave theory of light. If light were corpuscular, like a particle, instead of wave-like, it would behave like the balls, and the screen would show two strips of light corresponding to the two slits. That didn't happen. Later, it turned out that electrons and protons behave exactly the same way, showing that they also seem to exist as waves and not as points. There was one assumption that perhaps light and the others were particles, and that somehow the particles bumped into each other and flew apart.
This is where the weird begins.
To test this, physicists decided to shoot electrons at the target one by one, single file. And what do you think happened? The strangest thing imaginable. The interference pattern still appeared on the screen. It seemed that the single electrons somehow divided into two waves, passed through both slits, then interfered with themselves. Impossible. So physicists tried to find out through which gap the electron actually passes. They installed measuring instruments to check this. Another seeming impossibility occurred. The electrons stopped behaving like waves and began acting like particles, and left a trace on the screen of two distinct strips with no interference. They had to admit something completely mind-blowing, that the fact of our observation or measurement destroyed the wave function of the photons, causing them to become like points, corpuscular. The electron, under the influence of observation, behaved like a particle, flying through one slit and not through two.
You're not going to believe this, but we can change the pattern on the far wall simply by not watching which slit the photons pass through. I know it sounds crazy, but in every trial ever conducted, the outcome depends on whether or not the experiment was observed.
The double-slit experiment also proves another thing that's very important: the existence of parallel universes. Where the parallel universes exist in waveform as probabilities or possibilities based on the choices, observations, and/or measurements we make at the cognizant point of reference experienced by our psyche at any given moment in time and space while conscious, that either do or do not materialize into what we perceive as tangible physical matter.